Hello everyone, welcome to the Novel Ideas for a Prosthetic Hand video. We are the Wailing Whales and our novel idea is the use of polar bear grip on a prosthetic hand. Firstly, I would like to talk about the major problem faced by the prosthetic hand industry, which can be categorized into the weight of the prosthetic, the grip strength, the limitation of the flexibility, and the loss of haptic feedback. An average weight of a prosthetic hand is around 3 pounds. This weight, when carried to a longer period of time, can lead to chronic problems such as chronic back pains. To tackle with this issue, we thought about focusing on improving the grip strength of the hand itself, which would directly reduce the weight of the prosthetic hand. The proposed solution by the group were first the octopus arm and its suction cups, which are around 2,400 suction cups on a single arm, which is of length of 4.5 meters. Next came the gecko setae, which are micro hair-like structures which gecko use to stick to any type of surface. Then we thought about polar bear papilla, which are soft black pads on the palm of the polar bear, which increases the friction and improves the mobility on ice. And lastly, came the starfish and the tube feeds, which are millions of tube feeds on a single arm of a starfish, which uses the adhesion secretions to stick on any type of surface on the ocean bed. Thus, we came to a decision of using polar bear papilla, which seems like a more achievable and a feasible goal in the given amount of time.
We decided to use the polar bear for our inspiration for our modifications to our prosthetic hand because of the slip resistance the polar bear has and the increased friction on slippery surfaces. The actual modifications we decided to create were to try and replicate the hardness and the surface geometries of the polar bear paw to increase that friction within contact of slippery surfaces. The modifications we made to our hand were in the fingertips, the inner proximal digits, and the palm, all using a polar bear paw 3D printed out of Arione TPU, which is a flexible foam. This is what we created all of our modifications out of, and we aimed to replicate the geometry as best as possible using 1 millimeter diameter and 1/4 millimeter height cones, spaced at about 2.5 millimeters between each center.
To test the efficacy of our design, we put it through 3 different test cases, once with our contact patches covered and once without, applying roughly the same amount of force to close the hand for all cases. The first case was a dry, smooth metal object, namely a tall 12-ounce can. As you can see, the hand is able to pick up the can for both tests. However, the test with the patches exposed was better able to maintain its hold on the can when it was moved quickly up and down. The second case was testing our hand's ability to pick up an irregularly shaped object using the contact patches. As you can see, we are able to not only pick up, but also actually catch an apple using our hand with the contact patches exposed. The third case was testing the design on a slippery surface, and this is where our design really showed improvement. To test this, we coated the same can from case 1 in WD-40, making it very slippery to the point where the hand was unable to pick it up when the contact patches were covered. With the contact patches exposed, however, we were not only able to pick up the can, but shake it up and down without it dropping, a clear improvement over the regular hand.
Yeah, go.
Oh,
Shake it a little.
Yeah, go shake it a little.
Oh,
Hey.
actually, that is worse.
That like sure. Ready?
Great, I'm on. Yeah. Yeah. Amazing. Da-na-na-na-na-na.
See?
Wow.
Perfect.
It does
Oh yeah.
nothing. Yep.
Yep.
They can still grab it.
Chuck, 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 chuck. Yeah, that's
good.
good. Yeah.
Hey, let's see how she works.
Nice. Now shake it. Yeah. There we go.
Chuck, chuck. Now drink from it. Damn.
Okay, so from the previous videos, we obviously observe a significant increase in performance. And so why do we implement these modifications? So of course, we do see a strong increase in the gripping ability, as shown by the can sprayed by WD-40. Only the modified prosthetic can are able to grip the can. We did not sacrifice any range of motion by adding on the pads, and we were able to grip on different shaped objects as illustrated by the apple, having a hard time sinking while we were picking up the objects. Also, the force that are applied are still relatively high, even though it is somewhat lower than the original design. We would like to, in the future, upgrade our design to have a better grip for a wider range of shape of objects. And also we wanted to be able to print our hand with a material with a lower A value. So that would conclude our video, and thank you everyone.